Okay, so I think this is the 18th of May quiz. Let's go over the first question. A study was conducted to determine if taking vitamin C reduces the occurrence of the flu. The study was conducted using 808 student volunteers who did not take a flu shot. The subjects were randomly assigned to one of two groups, a treatment group who received 1,000 milligrams of vitamin C daily, or a control group who received a placebo flavored to taste like the vitamin C treatment. All participants were monitored to ensure that they adhered to their assigned treatment on a daily basis throughout the period of the study. At the end of the flu season, each subject's medical record was reviewed by a physician to determine whether he or she had contacted the flu during the period of the study. The physician did not know which treatment each subject received. The result of the study are shown in the table below. Even before we really tackle the questions, you should be really thinking what's going on in this experimental design. For example, this is a random assignment, right, which is important. And then there was a control group with the placebo, but it was also a blind. There was a double blind because the participant wouldn't know which treatment that they're taking because there was a placebo that tastes like vitamin C, but also the physicians didn't know the treatment that was administered to the subject. So that's a double blind. So even if that's not the question that they may be asking here, you might be wanting to know how to maybe set up that kind of design just in case the questions ask for the experiments, including the double blind and things like that. All right, so part A is asking, is this study an experiment or an observational study? Explain your answer. And this is a quite straightforward question. You should have a straightforward answer. So is this a study, an experiment or an observational study? So your answer should start with, this study is an experiment. And then you need to explain why it's an experiment, right? Because it says there were treatments. An observational study, there is no interference or involvement from the outside. So this one, you need to mention something like, there were treatments imposed to subjects, or there were random assignment of treatments to the subjects and something like that. And treatment is the most important word here because that indicates that this was an experiment with some control and non-observational study. Part B. Based on this study, a health expert claims that there is evidence to suggest that vitamin C reduces the occurrence of the flu in the population of students who would volunteer for such a study. State the name of a test and the null and alternative hypothesis that the health expert could have used to support this claim. Do not carry out the test. So this one, they just want to see if you can set up the appropriate hypothesis and also name which tests you would be doing without actually carrying out the test. All right, so this one, because we are counting, we know that this is a proportion problem, right? We are dealing with we're dealing with discrete numbers, right? And so this one would be proportion because you would be more likely measuring what percent of people would have gotten the flu or not gotten the flu. So it's a proportion. And since we have divided into two groups, it would be two proportion z-test. I've noticed that some of you use the two sample z-test for proportion, but we do prefer the proportion being in front just in case that you forget to write proportion at the end. Because if you write sample in any ways, usually in an AP Stat exam, they treat that as like a mean question. So you want to emphasize the word proportion. And then it is a z-test, right? Because of proportion, we always do z-test, and there was no such thing as a two proportion t-test, okay? So you need to match them well. And the hypothesis, if you didn't make it very clear, for example, I think sometimes they assume that if you write like P of C for vitamin C, like if you made it clear, then like sometimes you don't have to define what P of C refers to. But it is very wise for you to actually define what you do, especially if you use something like P1 and P2. There's no way I can distinguish which one you're referring to. And there was a typo in the answer. This should be the other way. So I think this was another portion that you got confused, and maybe it's just like how you defined it, right? It says occurrence of the flu, right? Reduces occurrence of the flu, meaning that you want the lower number for the treatment. So the PFT, this was a treatment of the vitamin C, right? So you want this number to be less than the placebo group, because then that will give you an idea that it will suggest that the vitamin C reduces the occurrence of the flu. But I think some of you mistook that statement and then did greater, so then it's not right for alternative hypothesis. Null hypothesis, it was that there was no difference. Okay, and so two parts that were important for this one was that defining your variables. So especially if you start writing the variables in your test, defining variables, you really need to explain them, okay? And then you need to correctly claim your hypothesis. I think the alternative hypothesis was the challenge. Null hypothesis, I don't think any of you got it wrong. And know that which test is used for what. I think I already shared like a cheat sheet for which test is appropriate for which situation. So maybe review that. And I will like post that up again so that you can easily find it. All right. So this was how you got your points for part A and part B. I will just mention, so I think there were a couple of you who said it was a chi-square. It's not a chi-square. It's two sample z tests for proportion. Like I said, if you write it exactly like this, that's completely fine. But two proportion z test is also very, very fine, okay? Yes, again, if you look at it here, you can see how they are looking for the essentially correct answer. You have to define each of your variables. And if you fail to do that, or if you did the other way around for the alternative hypothesis, then you earn the P instead of E. And that was it for actually number one. It was a very short question. Number two, a tire manufacturer designed a new tread pattern for its all-weather tires. Repeated tests were conducted on cars of approximately the same weight, traveling at 60 miles per hour. So that is the control part of this experiment, right? The tests show that the new tread pattern enables the cars to stop completely in an average distance of 125 feet with a standard deviation of 6.5 feet, and that the stopping distances are approximately normally distributed. Okay, so there are some information that I might write it down if this was a test. All right, what is the 70th percentile of the distribution of stopping distances? Okay, so a lot of you started writing something like, what was it, like px equal 0.7 or something like that. But like you need to define what x is, or else this makes no sense to me, okay, or the readers. So here what they did is that let x denote the stopping distance of a car with new tread tires. And then they said that x is normally distributed. I know this was on the question, but this needs to be mentioned in order for them to know that you know how to use this information. So if you wrote this notation somewhere in your answer part A, then that would have been satisfied. Okay. All right. So then the z-score corresponding to cumulative probability of 70% is z equals 0.52. So how do they find that? Well, it's a 70th percentile, so they did inverse norm of the 70 with the standardized, what's it called? So, oh, sorry, I'm using what am I doing? I want inverse norm. So if you do that, if you do inverse norm 0.7, 0, and 1, you get 0.52. So then what they did was that 0.52 times 6.5, which is your standard deviation, because here is your mean, right? And then it has to go 0.52 more. So, but you can also do 0.7, comma, 125, comma, 6.2. Okay, it will still, I think if you do that, you get 128.25, which is not 100. Oh, I don't know why I get 128.25. It says 128.4. But here it says if the calculator command inverse norm is provided along with this, it should be correct, partially correct. I think the reason is you didn't give the distribution sketch. So I know that we always practice sketching them, and that we talked about that it won't be necessary for this year because that they said that you'll be able to type everything. And so that's why I think it is very important that you kind of steer away from this kind of answer. If there is a way for you to write the answer without you using the computer command, then you should write it that way. And even if you use a computer command, you must be able to identify what each of them means. So I guess this is not okay unless you provide the sketch, but this is okay because you're providing every thing, and then you're labeling everything so that the readers can know what you're talking about. So please, I think a lot of you gotten better about that. In the beginning, you only wrote inverse norm, but then a lot of you are now writing what they each mean and then correctly labeling them. So I'm not too worried about it, but just remember that just writing the calculator command does not give you an E, okay? And that's a very easy way to lose a point, even if you know what you're talking about. So please don't do that, okay? So that was part A. Part B, what is the probability that at least 2 cars out of 5 randomly selected cars in the city will stop in a distance that is greater than the distance calculated in part A? So part A, the distance was 128.4. So obviously, if you didn't get the correct distance, they will not take points off as long as you did this part of mechanics correctly. So first, you need to be able to recognize that this is a binomial distribution, right? So here is a cumulative probability of 0.7. And then, so then the stopping distance greater than this, part A, would be 0.30, because if this much is 70%, then obviously greater than that will be the 30%, right? And the Y denotes to the number of cars with the new tread pattern out of 5 cars that stop in a distance greater than 128.4. And here it says Y is a binomial. So some of you would go through each conditions to say that this is a binomial. And it is still important that you mention the notation, which is this, right? Binomial notation is always a capital B, parentheses, N, your number of trials, comma, your probability of success. So this would be sufficient. You wouldn't have to write it out that Y is a binomial random variable with N equal 5, blah, blah, blah. I think this is the part that you guys get confused a lot. When do we subtract from 1 and when do we not? I think one tip would be write it out what it says. It says at least 2 cars will stop in distance greater, right? So that's that. But then we know that binom CDF only calculates from the 0 to whatever. And another thing that you guys really need to remember about binomial distribution is that it's a discrete random variable, meaning that you don't get to calculate 1.2. It's always 0, 1, 2, 3, 4, 5. That's why it's that you should write it as y is less than or equal to 1. You don't even have to write, oh, why did I write 5? 2. Sorry. You don't even have to write 1 minus p, y is less than 2, because this is a discrete random variable. This is fine, and the reason you should write it this way is that then you don't forget the binom CDF. You just write 1, right, and then 0. So that's basically what's going on here. So it did 1 minus y is less than or equal to 1, and I got the measurement, and I got 0.4718. Let's see. It says, as long as the students identify the distribution and parameter, like this notation, the binomial formula does not need to be set up to receive full credit. So do you see how important it is to state that what kind of distribution you're working on, right? Okay, again, so if you write that, even if you just write 1 minus binom CDF, they're gonna give you full credit instead of like a partial credit, okay? Again, here you can see that without this notation, you would not get essentially correct. So make sure that whenever you choose, so if you're calculating the z-score, right, or you're using normal CDF or inverse norm, you should write somewhere in your answer that this is a normal distribution, or you have a reason to believe that this is approximately normal for you to use that. If you're using a binom CDF, you should be indicating that it is a binomial distribution before you go into using those formula. If you haven't done that, it's almost setting up, like it's like the foundation of what you're doing. And statistic is basically providing evidence for everything that you're doing. And if you just jump into the formula, they have no idea why you are using those formula, okay? Because as far as they know, that they are not, as far as they know, they are not sure that if you know the different distribution and those different distribution use different formulas for each of the calculation, okay? So for them to understand clearly that you understood this concept, you must start by writing what kind of distribution you're working on. And if you need to state why you could use those distribution, say so. Part C, what is the probability that a randomly selected sample of 5 cars in the study will have a mean stopping distance of at least 130 feet? All right, so we want at least 130 feet. So we are going to use a normal approximation, I think, because it says approximately normally distributed. And the reason we are steering away from binomial is because that we are randomly selecting 5 cars. So it's not like we want to have like a 2 out of 5 cars or at least 3 out of 5 cars kind of thing. It's like, okay, what is the probability? So we need to say that distribution of this is normal with 125, but then the standard deviation would be 6.5 divided by square root of 5, because we are selecting a sample of 5, okay? And I define what X is. You don't have to write X bar, you can write it X, but this one, since it did X bar, we're gonna just use X bar. So X bar is at least 130 feet, okay? And then, but I think the reason that they didn't do equal to it is that, do you remember in normal distribution, you don't do like that specific point because it's 0. Z is greater than, you need to find the Z-score, right? Like this, there's a typo here, it should be division there. And then, so then you get P of Z 1.72. And you can just write 0.0427. Again, at the point when you are here, guys, you can just do normal CDF, okay? But you don't have to write that you're using normal CDF, because again, if you use normal CDF, it wants you to sketch and label the normal distribution. Obviously, if you actually write out what each command means, then it's fine, okay? So this is where we would have graphed the sketch as a 130 here, 125 here, and then sketch right here, because that's what we are interested in. We want at least 130 feet. So same thing, mistake, your mistake wasn't that you couldn't find this answer, that your how you're writing your answer wasn't complete enough for me to give you an E. And it's a very small thing, like not mentioning that this is a normal distribution, or it's a very small thing as not labeling what your calculator command meant, okay? So please pay attention to those things, because again, you know how to do this. You don't want to lose your points in the things that you already know how to. I think this is the 10th, the 17th of May, the weekly FRQ. Our large university offers STEM, which is a science, technology, engineering, and mathematics, huge field. They give you lots of scholarship. Internships to women in STEM majors at this university. A woman must be 20 years old, 20 years or older to meet the age requirement for the internship. The table shows the probability distribution of the ages of the women in STEM majors at the university. Okay, so again, this is discrete variables. A, suppose one woman is selected at random from the women in STEM majors at the university. What is the probability that the woman selected will not meet the age requirement for the internship? Well, the age requirement was 20, right? Or older. So it's anyone that is not 20. So anyone who's age of 17, 18, and 19. So you just add up these probability and you get 22.3%. Please show your work. Because especially when it's a rounding up or rounding down question, because they give you P as a 1/2 point, these things do matter, okay? Because this is a way of you showing clear communication. All right, see, you need to show work to get an E. Let's see, part B. The university will select a random sample of 100 women in STEM majors to participate in a focus group about the internships. Suppose a simple random sampling process is used to select the sample of 100 women. What is the probability that at least 30% of the women in the sample will not meet the age requirement for the internship? All right, so this one, we have a fixed number of women, right? And it's wanting that at least 30%, that means at least 30 people, right? Will not meet the internship. So we can say that this is a binomial, right? Because it's a pass or fail. You either is the age of, like the age, you met the age requirement or you didn't meet the age requirement. So it's a binomial of 100, 0.223. And then we are going to say X represent who do not meet the number of women who do not meet the requirement. I'm not going to rewrite it because it's written here. So what you do is that X is at least 30, right? Because 100 times 30% is 30 people. So we want at least this people. To use binom CDF, you want to do 1 minus P of X less than or equal to 29. Again, because it's a discrete, you don't have to say X is less than 30. Continuous values are only for normal distribution, but binomial distribution is a discrete variable. And when you do this and use a binom PDF, binom CDF, you get 1 minus 0.9547. So it becomes 4.53%. Okay. So what's neat about writing this way is that you don't really need to show binom CDF or how you are getting those numbers. All they care about is that, can you show me enough work that I can follow what you're doing? And so that's all it is. So make sure that you can write it this way. And whenever you write X, ask yourself, do I know what X is? Of course you do. Does the person who's reading this know what X is without me telling them what X is, right? So please, as soon as you start writing a variable, define what it is, okay? You need to be really starting by this, okay? That's not just a sentence to fill it in. It really is essential. All right, part C. Suppose a stratified random sampling design is used to select a sample of 30 women who do not meet the age requirement and a sample of 70 women who do not meet the age requirement. Okay. Based on probability distribution, is a woman who does not meet the age requirement more likely, less likely, or equally likely to be selected with the stratified random sample and with the simple random sample? Who do meet the age requirement? Okay, 70 people meet their age requirement, and 30 is who do not meet their age requirement. All right. A lot of you did give me the right answer, which is the stratified random sample is more likely. So here, a woman does not meet the age requirement, is more likely to make it into the stratified sample than the simple random sample. It's because, but then the justification was kind of different for different people. But the justification should be what you got from the first part A, which was 23.3%, right? But the stratified sample, the actual percent, do not meet the age requirements set at 30%, right? Because 30 people out of 100 people, right? So that's why that you say the woman who does not meet the age requirement is more likely to make it into stratified sample rather than the simple random sample. So it doesn't matter whether you say stratified random sample is more likely or that be the last, you need to show both the justification and also the answer, okay? Don't just write the justification and stop there. You need to actually answer the question, okay? And that's it for this question. This one was very hard for a lot of you. So let's get this together. I chose this problem because there were a lot of parts, which is going to be like your actual exam. And also there was a lot of kind of like it's an investigative test, more like number 6s. And so I just wanted to throw something out there in case, because I have no idea what kind of question that they will come up with, right? All right. Emma is moving to a large city and is investigating typical monthly rental prices of available one-bedroom apartments. She obtained a random sample of rental prices for 50 one-bedroom apartments taken from a website where people voluntarily list available apartments. All right. I think some of you got really tripped up by this word, voluntarily list. But that's not how I designed the sample, right? My sampling was random sample, so it's okay. I could generalize something, okay? Because it was a random sample. Voluntary sampling, for those of you who are still confused, is that you let people answer. This wasn't so. Like the answers, so it's like the data might be there voluntarily, but within that, you still randomly select a sample, and it still satisfies as a random sample. Okay, so don't let just that one word throw you off. Just read everything and see if this was a random sample or was this a voluntary. Okay, based on who is collecting the data. Okay, if this was a website, obviously you can say it's a voluntary sampling, but website isn't concerned about the data. It's Emma, right? Emma is still collecting a random sample. I think part A, some of you didn't read the question. It doesn't say describe the distribution. It says describe the population, guys. Population is what we are interested in. So you should be really stating what could be the population, right? For this. How would you define the population for the sample that she collected? So read your question carefully. Just because it said describe and give you a graph doesn't mean describe the distribution. It has to say describe the distribution, or else you're not doing socks, okay? So part A, I think it was you are just rushing and you are not reading the question carefully. So some of you just described the distribution, which is like not the question, what the question is asking. So part A should be answered like this. Because the random sampling was used, you could generalize the population. And then your answer really should be this: rental prices for one-bedroom apartment in the city that are listed on this particular website at the time the sample was taken, right? We're not interested in one-bedroom apartments in the entire state. We are just interested in this city because this website, right? This website is basically for this city, or else it doesn't make sense, right? People wouldn't really post their apartments if they aren't from this this city. And here, that's what she wanted to investigate, right? So, but she took the sample so that she can infer about what she wanted to investigate. So the answer for part A was really in the question, okay? So if you read the question correctly, you would have answered it correctly. Part B, Emma wants to estimate the typical rental price of a one-bedroom apartments in the city. Based on the distribution shown, what is a disadvantage of using the mean rather than the median as an estimate of the typical rental price? So a lot of you, I saw two kinds of answer. I saw people saying outlier, and I saw people say skewness. Outlier is a very specific language in statistics, right? Outlier is an extreme value that is at least 3 standard deviations away. If you have no confidence that this might be an outlier, don't say it's an outlier. Just say it's skewed, okay? Because outlier has a mathematical way of, like, you can prove if something is an outlier mathematically. If you can't do that, if they don't give you enough data to do that, don't say outlier. Say it's skewed to the right? Or you can say it's positively skewed. So use the word, because this is a skewed graph, right? But can I be sure if there's an outlier? No, I can't unless I carry out the calculation. So don't use outlier, use skewness. And I know this is my fault because I kept saying pull to the right, pull to the left, but that's not very technical, right? So I want you to use a word like overestimation or underestimation, right? Obviously, if it's a pull to the right, it would be an overestimation because the values are higher on the right, and it would be underestimation if it's a pull to the left. So just switching the words so that it sounds more, you are clearly communicating. Me saying pull to the right is for your understanding, but now that you have understood, let's switch the word so we can say it's overestimated or underestimated, okay? So I think there are a couple things that you have to look for, that you have to say that median was a better choice. Mean has a disadvantage. It's because that mean would overestimate values due to the skewedness of this graph. Okay, I think that would have been a sufficient answer. Part C, instead of using the sample, okay, I get this question. This question wasn't very clearly written because the question kind of happens in the middle and then it carries on with something totally irrelevant for part C. So some of you really didn't know how to answer this question, and I think it's because you didn't know what the question was. All right, instead of using the sample median as the point estimate for the population median, Emma wants to use an interval estimate. Okay. However, computing an interval estimate requires knowing the sampling distribution of the sample median of sample of size 50. Emma has 1 point. Her sample median in that sampling distribution, right? So that would be the point estimate, right? Point estimate is at one single point, and then when we construct a confidence interval, we have an interval estimation, right? Let's see, using information about rental prices that are available on the website, describe how someone could develop a theoretical sampling distribution of the sample median for sample of size 50. This was the question, guys. This is a question for part C. Describe how one would develop a theoretical sampling distribution for this size. And the answer should have been just, because we know how to create a sampling distribution, right? And I think some of the vague wording was that many samples of sample size 50. I didn't give you an E for that because many sounded a little vague for me. The word that you should have used is that every possible. sample of 50. What kind of sample though? Well, one bedroom, where is the wording? One bedroom apartment from this website, right? Because that's why they keep mentioning this word available on the website, because you're not looking for any other information, or you're not going anywhere else. You're looking for the data on this website. So what you do is that you repeatedly get sample size 50, but you really should mention every possible sample, because that's why it's a theoretical, right? And that's why we use computer software to actually come up with that, because it's not humanly possible to get every possible sample of 50, but computers can do that. So as a method of how one should develop sampling distribution, well, this person should obtain every possible sample of 50 one-bedroom apartments from this website. And then that's one part, but another part that is very important is that you have to compute median for each sample that you've collected, right? And then that's how you're creating the sampling distribution for the median. Usually it would have been mean, but because this one is median, that's why you use the word that you have to compute median, or you have to calculate median. And when you collected all the possible sample medians, then you have your sampling distribution. Does that make sense? This question I think was actually really great, because it asks you if you understood the concept of sampling distribution, which is often very confusing to a lot of people, especially when you are new to all this concept. So just know that how you can come up with the sampling distribution, and how you use the sampling distribution and all that, okay? And it doesn't have to be mean. Especially a question like this, if they were asking for median, just say you calculate the median for every sample that you have collected. All right, so this one, and then they describe the bootstrap method, I think, bootstrap process of like how she collected all this data. Part D was asking, use the frequency table to find following: value of the 5th percentile and value of the 95th percentile. Well, there were 15,000 medians. So to find the 5th percentile, we need to multiply 0.05 to see what value I get. I get 750, right? So then you count when the 750 happens. If you start adding, you will notice that 750, you become 750 here. So I think some of you got a little confused and said between 2,497.5 and 2,500, there's no such thing as that, okay? Because this is a discrete number, and you can pinpoint where 750th number happens. Well, it happens here, because 750, so up to this point, it would be less than 750, right? But then once you add 1899, it becomes over 750. Well, that means your 750th number was here. So the answer is 2,500 for the 5th percentile. 95 percentile was this. So you could go backwards, or you could continue adding until you get 14,250. And that happens here, 2,000, where is it? 2,950 here. Okay. So this one you could have start subtracting until you hit 14,250, or you can continue adding until you go over 14,250. So like you added it, and then the number goes over 14,250, then you know that number you just added is the point, okay? So that's why the answer was 2,500 and 2,950. Part E, find the percentage of bootstrap medians in the table that are equal to or between the value found in part D. All right, so what you do is you have to, sorry, you can probably not see. So basically what they did was you do, where am I? Sorry, 14,404. So it's a equal to or in between. So basically what they did was, oh, no, let's do it this way. So basically what they did is that they subtracted everything that was not here, because you could be on this as well. So if you add all this value in the middle, that's more work than just subtracting everything that was outside. So once you do that, you get 14,400. I got 401, but maybe I had a typo. And then out of 1,500, right? Because that's a total. Basically, they are asking what's happening in this middle when this was a 2,500 and this is 2,950. So that's what they were asking, and it was about 96.03%, which leads to the next question, right? Use your values from parts D and E to construct an interval confidence interval for the median rental price. So this one, this is about 96.03%, right? So we can say about 96%. So we can say we are 96% confident that the true median rental price, or the median rental price for of all one bedroom, right? This all, and then the word true. We use that to indicate we are talking a parameter, not statistics. One bedroom apartment listed on this website is between these two values that we found from D. Okay. The reason this is 96% is because that's what we found in E. Remember, confidence interval is always the area. So either this was a 90% or 95% or 99% kind of thing, and the area happened to be about 96%. So this would have been perfect that you wrote approximately or about 96%. And that was it for this question. And I think this question was very hard for a lot of people, just because the questions were unlike what we've seen. It's like, it's something that we know, but the questions were worded in a way that we are not very used to. So I think this question was hard for a lot of people, but know that the content is everything that you know already, okay? And I'm afraid that like the questions that you will see on the exam tonight will be more like this. And so read your question carefully. I think this is the last two questions I have. This was this week of 17. Not many people did it, so I will go over it quickly. Sunshine Farms wants to know whether there is a difference in consumer preference for two new juice products, Citrus Fresh and Tropical Taste. In an initial blind taste test, 8 randomly selected consumers were given unmarked sample of the two juices. The product that each consumer tasted, it's like a tongue twister, first was randomly decided by the flip of a coin. Okay, so it's a random assignment. After tasting the two juices, each consumer was asked to choose which juice he or she preferred, and the results were recorded. Part A. Let P represent the population proportion of consumers who prefer Citrus Fresh. Okay, so they already defined the P for you. Good. In terms of P, state the hypothesis that Sunshine Farm is interested in tasting. They want to know that if there is a preference, right? So if there is a preference, then you would say it wouldn't be half-half, because it's basically you're choosing, you only have two choices. So if there is no preference, it should give you 50%, 50%. So I can see that some people might take this as like a chi-square test, okay? But it's not, okay? Just use a sample, one proportion Z test. So the P is, especially because they define P as a preferring Citrus Fresh. So that would be 0.5. And if there was a difference, right? If someone preferred Citrus Fresh, the population prefers Citrus Fresh or not prefers Citrus Fresh, well, we know that it wouldn't be 50%, right? And so part B. One might consider using a one proportion Z test to test the hypothesis in part A. Explain why this would not be a reasonable procedure for this sample. Okay, so why wouldn't it be reasonable? Well, you think back to all the conditions, right? And one of the conditions is that you have to have a large sample, which is an NP, and NQ has to be greater than 10. Okay, the reason we are using NP, not NP hat, is because this is a hypothesis test. Okay, confidence interval, you use an NP hat. But for hypothesis test, you use NP. And unfortunately, it's not. It's 5. It's 4. It's not even 5, okay? It's because your N was such a small number. And that was it for part A and B, okay? Part C. Let X represent the number of consumers in the sample who prefer citrus fresh. Assuming there is no difference in consumer preference, find the probability for each possible value of X. Record the X value and the corresponding probabilities in the table below. So X will be binomial in this case, right? Because if you assume that there is no difference, then it would be 0.5. And then you have a number of trials being set, which is 8 people, right? So you will say the success thing 0, 1, 2, 3, 4, 5, 6, 7, 8. You can use a calculator for that. You don't need to show all the work. I don't think to earn everything, you just need to state this, right? Again, the stating this is the most important part. Hopefully you know how to do that. You can use binom PDF for each one of them. Part D, when testing the hypothesis in Part A, Sunshine Farms will conclude that there is a consumer preference if too many or too few individuals prefer citrus fresh. Based on your probability in Part C, is it possible for the significance level probability of rejecting the null hypothesis that when it is true, for the test to be exactly 0.05? Justify your answer. Okay, so the answer was no, there is no possible test with a p-value of exactly 0.05. Okay, the probability that none of the individuals or all the individuals prefer citrus fresh is 2 times, because this is the value, right? So it's about 0.0078, which is less than 0.05. The probability that one or fewer of the individual, sorry, I can't see because of this. X is greater than less than or equal to 1 or 7 or more of the individual is 0.070312, which is greater than 0.05. Interesting. Is it possible? So what they're saying is that it won't be exactly 0.05, right? Because if you do 0 and A, which is the most extreme, right? If this is like 0 and 8, the most extreme probability is less than 0.05. And then if you go one more, it's greater than 0.05. So there is no way that you are exactly on 0.05. Although this question, I think it would have been hard if you got it, because it seems very vague how it communicated. But I hope that makes sense. It's because, remember, p-value is the area, right? P-value is the area, and if the significance level is 0.05, so like probably rejecting the null hypothesis, right? So p-value, so that's why they are combining the area, because the hypothesis, alternative hypothesis, was that p is not equal to 0. If this is just a one-tail test, and you would have just added the one tail, but because it's a two-tail test, that's why they are adding both sides, 0 and 8 and 1 and 7, and then so forth. All right, part E. The preference data for the 8 randomly selected consumers are given in the table below. Based on these preferences and your previous work, test the hypothesis in part A. So the P, if you remember, was the who prefers citrus fresh, right? So we have to count how many people prefer citrus fresh. There are only 2 people. So then more than, so the probability that the fewer than 2 people or more than 6 people, because of the, what's it called? Because it's a two-sided, two-tail test, is basically you're adding these and then adding that, right? And so that's how they got this number. and it's greater than any reasonable significance level, right? Because this is basically p-value. When you're adding the area, you're getting the p-value. So 0.289 is greater than 0.05, 0.01, 0.1. So that's why they say that we would fail to reject the null hypothesis, right? Because p-value, I know there's a lot of p here, but this is p-value. 0.289 is greater than any significance level, which is alpha. So that's why we say we fail to reject the null hypothesis. We don't have enough evidence to support that the consumer preference is different, right, between the citrus fresh and tropical taste. Okay. F. This is a long question. I think that's why I picked it actually. Sunshine Farms plans to add one of these two new juices. A follow-up study will be conducted to decide which of the two juices to produce. Make one recommendation for the follow-up study that would make it better than the initial study. Provide a statistical justification for your recommendation in the context of the problem. So one of the things was that it failed to satisfy the large enough condition, right? So that's why they said increase the number of consumers involved in the preference test, right? And so then that you'll be able to detect the difference. Again, it has something to do with the power of your test, right? Because when we want to increase the power, we increase the sample size. By increasing the consumer, so let me see how they correct it. So provide reasonable recommendation in the concept comparing preference for the two juices with an appropriate statistical justification. For example, the student describes the impact of a large sample size on a hypothesis testing procedure used in the initial study by saying the increasing sample size will reduce chance of making a type 2 error. Increasing the sample size will increase the power, right? Increase the power. So if you talk about those things, then you are essentially correct. Okay. So again, I know power is a concept that can be difficult to understand. So that's why I posted that video that are recorded by those two guys from the College Board, because I think it is very helpful to review that. So that if the question like this comes up, that you know exactly what the problem was and why we have to have a large enough sample to carry out the hypothesis test. All right, number 2. Regulations require that product labels on containers of food that are available for sale to the public accurately state the amount of food in those containers. Specifically, if milk containers are labeled to have 128 fluid ounces, and the mean number of fluid ounces of milk is in the containers is at least 128. The milk processor is considered to be in compliance with the regulation. The filling machines can be set to the labeled amount. Variability in the filling process causes the actual contents of milk containers to be normally distributed. Okay, good to know. A random sample of 12 containers of milk was drawn from the milk processing line in the plant, and the amount of milk in each container was recorded. Part A. The sample mean and standard deviation of the sample of 12 containers of milk were 127.2 ounces and 2.1 ounces respectively. Is there sufficient evidence to conclude that the packaging plant is not in compliance with the regulation? So this is basically carrying out the hypothesis test, right? So we have to say the correct hypothesis. The mu, I guess they didn't define the mu, but you really should defining by mu is the true true number of fluid ounces of milk in the container. Right. So the null hypothesis would be that it's equal to 128, and the alternative would be less than 128, because if it's at least 128, then you are good, right? We are going to do one sample t-test, so do say that. because it would be a lot harder to write this on this kind of test. Condition, well, it said it's normally distributed, so even though my sample size is tiny, that we can assume that it will be normal. So the normal condition is satisfied. It was randomly taken, so random condition is satisfied. What else? 10% condition will be probably satisfied too. Use correct mechanics. If you know how to write the formula, right? So the mean, the bar, x bar is 127.2 minus 128. If you're writing this on a computer, you will write it like this, 2.1 divided by square root of your sample size, which is 12. So then you get negative 1.3192. And then the p-value, you can just type all of this in the calculator, but p-value, please just give your degrees of freedom, which is 11. P-value will be 0.1070. Okay. So since the p-value is 0.1070, that is greater than any alpha, really, right? Because our conventional alpha value will be 0.1, 0.05, 0.001. And so we don't have enough evidence. So we fail to reject null hypothesis, and we don't have enough evidence to support that it's the company is in compliance with the regulation, the refute the claim, right? Because it's basically saying the alternative hypothesis being that it's less than, meaning that they won't be complying. And so part B, inspectors decide to study a particular filling machine with this plant further. For this machine, the amount of milk in the container has a mean of 128 and then standard deviation of 2. What is the probability that a randomly selected container filled by this machine contains at least 125 fluid ounces? Well, we have to assume that this is normal, right? Because it's a normally distributed and it's a 128.2. So I will write that, okay? Because you need to use the z-score here. So x, define x, okay? X is greater than or at least 125. So then find a z-score. Z-score is this. So, so we do 1 minus of that, 0.0668, which is 0.9332. The reason we do that is the step that's missing is this. 1 minus, okay? So 93.32%. Part C, an inspector will randomly select 12 containers filled by this machine and record the amount of milk in each. What is the probability that the minimum recorded in the 12 containers will be at least 125 ounces? Analysis wants to use simulation to investigate the sampling distribution of the minimum. The analysis randomly generates 150 samples, each consisting of 12 observations from a normal distribution with mean of 128 and standard deviation of 2, finds a minimum for each sample. The 150 minimums sorted from the smallest to largest are shown right here. What is the question? The question is, what is the probability that the minimum recorded in the 12 containers will be at least 125 ounces? Well, so we have to see how many there are. Let's see, at least 125 ounces. So here, okay, I'm a little confused here. Smallest. Let me look at this. I feel like that graph wasn't really necessary. Let's see. 150 minus 66. So, okay, I'm trying to figure out what this, so I think what they did here, let me try this. City of at least 120, at least 125, right? So basically what they did here is that they used normal CDF to actually find, I mean, I think we found it already, right? So they used whatever we use in part B. So the 0.9332 as the probability, and then they did 12 because you're finding 12 random things. But then when I did basically 150 minus 84, and then divided by 150, you get 0.44 as well. So like if you have rounded it up, it would be the same. But I don't know if that would be what they were looking for, or I'm not so sure if they would have given you the point by doing it this way, because I don't understand why they gave you this table if we aren't going to use it for this problem. But basically it's a part B followed up by part B, and you're using that probability that you found from part B and then doing the power of 12 because you have 12 containers. All right, use the simulation results to estimate the probability that was requested and part, oh, so this is where you use it. All right, so you do have to find it this way for part C, and then this is for part D. Looking at the sorted, so there are 66, right? So that's how I got 0.44. And the difference between a 0.003A, which is very small. So the simulation provides a very good approximation, blah, blah, blah. Okay. All right, so as long as you found the part C correctly, part D would have been fine. I think the confusing part was that they put this simulation result in part C as if like you would have to use this to solve for part C, which wasn't the case. The simulation was only used for part D. All right, so this one I wanted to show you that why sometimes you get score up and then score down. So reason to score up is that your notation is all clear and clearly marked, clearly defined, probably. And all explanations are clear, that there is no, like, it would be very easy for me to follow what you're saying. And then you shouldn't include any wrong information, right? Especially if it doesn't answer your question directly. And you should not have any minor calculation error if they are not part of scoring, right? And interpretation parts are especially strong. So like you have interpreted it well, then you would be scored up. So like round up. If you had a 3.5, you get 4. When would you get 3 instead of 4 if you got 3.5? Your notation is wrong, or you didn't define them. Your explanations are not wrong, but they're very hard to follow. So you didn't clearly communicate. Or that you have put this extraneous information that was incorrect, or you made a calculation error, or that your E was not very strong in the first place, then you would round down. So I know this was a really long video. I will try to give you times where you should watch for what, but yeah, this is it. Hopefully this will be the last video I make for you guys. All right, see you later.